Hello again, this is our science teacher Tim Martin, and in this video we want to take a look at water in the Earth's atmosphere and go over some of the important vocabulary to understand more of meteorology. In the previous video we took a look at the three common states of matter, solid, liquid, and gas. We also looked at the 6 transitions. To go from solid to liquid, we can melt, or from liquid to solid, freeze. Liquid to gas, evaporation, gas to liquid, condensation. And of course, it's possible to go directly from solid to gas through sublimation or gas to solid through deposition. More importantly, what we want to do is look at the process that happens. And to go from solid to liquid or liquid to gas, we need to add heat. If we're going from gas to liquid or liquid to solid, we need to remove heat or give away the heat. This idea of latent heat or hidden heat is very important. A liquid or solid may have the same temperature, but because the atoms in a liquid are moving faster, they have a hidden or a non-sensible heat. Same goes for a liquid and a gas. The atoms and molecules of a gas move faster than those of a liquid, even though they may have the same temperature. This is an important idea that we'll cycle back to several times. But let's take a look at some of the vocabulary. Saturation to start off with. When the air is saturated, or we talk about the saturation mixing of air, what we're talking about is having an equal amount of evaporation and condensation going on. There's a certain amount of water that can go into air at certain temperatures, as displayed by this graph. You can see that at approximately 30 degrees Celsius, the saturation of air indicates that there would be 30 grams per cubic meter in air when the air is saturated. Or we could bring it down a little bit. If the temperature is around 10 degrees Celsius, we may have about 8 grams of water per cubic meter of air. Another term that is frequently used when we talk about water in the air is that of relative humidity. Relative humidity is a comparison of how much water is in the air to how much is in the air when the air is saturated. This, of course, depends on temperature. 50% humidity on a warm day versus 50% humidity on a cold day, there will be much more water in the air on the warm day, even though the relative humidity is the same. But how do we measure that humidity?
Okay, what I have here is a psychrometer. This, you can see, has 2 thermometers. One is dry and one has this small wet rag on the end of it. What I'm going to do is I'm going to take this rag and make sure it's wet, so I'm dipping it in some water. And I'm going to read the 2 thermometers. I want to make sure, starting off, we're at 28 degrees on the dry thermometer. And let's start swinging this around. We'll swing this for a minute or so, and the process here is, as we are swinging this around, evaporative cooling should take some effect and evaporate some of the water off of that damp rag on the wet thermometer. Alright, it's a pretty humid day, but let's see if we have a decent reading here. And the outdoor air temperature, maybe a little hard to read this, is 28 degrees on the dry thermometer, and it is about 25 on the wet thermometer. Let's take a look with the table and figure out what the relative humidity is.
So, this is the chart I was referring to, and the temperature that we measured outside with the dry thermometer was 28 degrees. So we'll highlight this row on 28 degrees on the dry bulb temperature. Now, the wet bulb temperature was 25 degrees. That gives us a difference of 3 degrees. So we'll highlight the column of the 3-degree difference, and you'll see where these two lines cross, 78%. the relative humidity this day was 78%. That's why it felt a little muggy outside. Let's try another example. Let's imagine that we had a cooler day and the temperature was 18 degrees Celsius. If the wet bulb temperature was 12, that would give us a difference of 6. We highlight the 6 column and quickly identify that the relative humidity on this day is only 49%. The greater difference between the wet and the dry bulb readings indicates a lower relative humidity. Keep in mind those differences are due to the evaporative cooling as the water evaporates off the wet rag on the psychrometer. There are other ways than a psychrometer to measure relative humidity. Have you ever had a bad hair day? This is my daughter. One day we were rock climbing this summer. It was a little bit humid, but humidity can be measured with hair. Turns out that human and animal hair stretches fairly significantly with humidity. Sometimes it stretches in a curly way, sometimes it flattens out. Many of you will recognize this from humid days. If you have a hairstyle, it may be less cooperative on a humid day. A hair hygrometer uses these principles. Hair is placed under tension with a spring and levers and attached to some sort of recording instrument or needle. As the hair shortens or lengthens, the needle changes positions, indicating the change in humidity. Some of the most accurate hygrometers are actually still made with hair. Of course, it's pretty common to use electrical hygrometers now. Electrical and electronic hygrometers use electricity to pass through some moisture-absorbing chemical, and that, attached to a dial, can give a readout of the humidity. But let's come back to the relative humidity table. Let's give one more example. What happens if we measured the temperature and the dry bulb temperature was 22 degrees Celsius? What happens if the wet bulb temperature was also 22 degrees Celsius? That would indicate no difference between the wet and the dry bulb reading. Well, that leads us to one final term in moisture in the air. Let's talk about the dew point. What happens if the air is saturated? Remember, saturation means an equal amount of evaporation and condensation happening. That would indicate that the relative humidity is equal to 100% if the air is completely saturated. So what happens if we drop the temperature down below the dew point? Well, pretty obviously, we'll start to see dew. Maybe if it's in the winter and the dew point is below the freezing point of water, we'll cut straight to having deposition and frost will appear. Alternatively, if it's higher in the atmosphere, we may see the formation of clouds. In the next video, we'll take a look at the processes for cloud formation. Thanks for watching, and have a great day.